Yes, it is visible that PPT I have shared the screen.
Sir, yes. So, sir, can you put it in full screen mode?
Yeah, I have given the slides full screen mode. Is it coming?
No, sir. No, it is not in full screen mode.
Yes. Now?
No, sir. Actually, this
No,
is
sir.
in Zoom. Actually, you have to go for the slideshow.
Is it full screen now?
No, sir. Actually, sir, do one thing. Just stop sharing your screen. After that, select your entire screen to share, sir. Then only it will be going presentation mode, sir. Yes, sir.
Yes.
Now it's
Yeah.
visible, sir.
Yeah. Okay. Good afternoon to all of you once again. Let me start this particular session. The topic of this particular faculty development program is Industry 4.0 and its various aspects. Under this particular heading of Industry 4.0, I have chosen one subtopic, which is I will be talking about the technologies and digital transformations in manufacturing sector. How the technologies have been evolved and digital transformation has taken place in the manufacturing sector. And I'll try to explain 2-3 case studies where the industries have been adopted and how they have got benefited from this particular technologies. We have already come across these terminologies in other sessions also, and various speakers, eminent speakers, they have given their lectures on each of these subtopics under Industry 4.0. So first I'll summarize for one or two slides. I will summarize about the Industry 4.0, then I will go to the technology part. There are 4 different industrial revolutions we have come across since 18th century, as we know. The first industrial revolution was in the 18th century, where the mechanical production actually moving away from the cottage industry, where the steam power or water power was used as an energy source. That was the initial stage of industrial revolution. After a decade, in 19th century, advent of electricity, which actually where we have seen the mass production system and assembly line, the development of those techniques. Then comes the in the mid of 20th century Industrial Revolution 3, or we can call it as Industry 3.0, where we have the automated systems come into the picture. And today we are in the era of Industry 4.0, where advanced robotics, 3D printing, Internet of Things. So these are the buzzwords or keywords we often go through in different platforms. These are the present scenario, which is coming under you, Industry 4.0. And chronologically, if we see from 18th century to the modern, to the present decade, we are going through all these industrial revolutions. And we actually, this has been named as a revolution because the innovation that drove them don't just slightly improve the productivity or efficiency of the production process. It completely revolutionized how the products were produced and how the work or operations related to the production were done. So as I mentioned, there are 4 different decades of industrial revolutions, first, second, third, and fourth. Presently, manufacturing is increasingly powered by information and automation. So vast amount of data which come from across the business and around the world in real time, round the clock. We need to handle this huge amount of data for different purposes. And this information or data, along with the automated technologies, are the heart of fourth industrial revolution, which actually allows the manufacturer not only gather all the data, but use it, analyze it, predict, understand, some report making, feedback, etc. And it is not characterized by a single technology. It is an integration of number of system, tools, and innovations. Industry 4.0. So if we can if we are asked to define what is the meaning of Industry 4.0, different literatures are available across the web, and there are different books which are available. The integration of intelligent digital technologies into manufacturing and industrial processes actually includes in this particular Industry 4.0, which encompasses a set of technologies, including IoT. We have come across this terminology, Internet of Things, or specifically for manufacturing and industrial sector, we have named it as industrial IoT networks, artificial intelligence, big data, robotics, automation, Industry 4.0, smart manufacturing, etc., which aims to enhance the productivity, flexibility, efficiency, while enabling more intelligent decision-making process, customization in manufacturing, and different supply chain operations. And as I have gone through the other lecture details. So I have seen that the eminent speakers earlier, they have focused, some of the speakers was focused on the robotics part, some has given different augmented reality things, additive manufacturing. So every aspect which is coming under the Industry 4.0 is covered in different sections. First keyword which is associated with the Industry 4.0 or fourth industrial revolution is the automation. Now, how we can summarize the role of automation in Industry 4.0? For automated production, actually, to unlock its value, it must be implemented as a comprehensive solution that encompasses all the firm's process and making it possible for information to flow through all the parts. And the added value of Industry 4.0 automation no longer focuses on only efficiency or profitability, but it also increases the flexibility and sustainability of the whole manufacturing system. And one of the important technique or key technique under Industry 4.0 is digital twin, which is a synonymous to our simulation, because not every time it is possible to have the real life experimentation for different reasons. There we can go for simulation, or we can make the digital twin of the whole process what we are going to optimize, or we want to go for any changes. So digital twin is one of the important technologies that actually monitors the process life cycle, exercising the virtual models that serve as a basis for making sound decisions. And we have seen that in processes where the margin of error can reach up to 10% when the work is carried out by a human being, or conventional manual labors are there. But when we are automating it, then that margin of error that will reduce up to a very low value in the range of 0.401% like this. Now, this is a pyramid which shows the first one, the above one, that shows the industrial revolution, different technologies, how the technological advancement has taken place in different industrial revolution stages. And the bottom one shows what are the different technologies that can be applied across the whole manufacturing system, starting from the workshop level or basic field level to the cooperative management or decision-making process. So in every stages of operation in the manufacturing industry, some degree of automation has been implemented, and it is the degree of implementation of the automotive technology has been increasing day by day. At the ground level or field level, we have different automated tools, equipments, fixtures. So there are many ground level equipments which can be used for the manufacturing purpose. For controlling the whole production system, we have different automated tools or automation technologies in supervision, production line, decision making. So everywhere some of the automated technologies can be used or technologies can be implemented for improving the productivity and in order to enhance the level of or the quality of the production. Now, if we implement different automated technologies, then what are the advantages we gain from this automation, which is the heart of any this particular industry 4.0 industrial revolution. First is the cost efficient part, cost efficiency, which reduces the labor cost, automating portions of the processes. In addition, virtual or augmented reality technology, simulation-based techniques that facilitate the learning process and improve the productive organization model. So these are coming under the cost efficiency part. This is one of the advantages of this automation, which is included in Industry 4.0. Competitive advantage, standardization and automatic redesign of procedures, making them constant and accurate. As a result, we get the increased productivity, capacity, and process quality, which minimizes the wastage or inaccuracy. Cost of downtime can also be reduced. So these are the competitive advantages can be obtained by automating the production system or manufacturing system. Scalability and flexibility, another advantage. Adding or changing tasks require training for a human operator, while robots and automated devices are reconfigurable and can be accurately programmed in a very small range of time, thus reducing the process execution and response time. So scalability and flexibility is another advantage in implementing the automated technologies. Time reduction, reduce the information processing time. The platforms with which automation works have a large capacity for the storage and management of data derived from the processes. So time reduction is another advantage. Utmost safety. The production line can assign machines or robots to hazardous tasks to pose a high risk to staff. In addition, advanced comprehensive security controls can be implemented for equipment, component, human resources. Cyber security is one of the essential technologies to safeguard the company's privacy. As we are relying on the Internet of Things and other information which are coming from the web, so cyber security is another key feature in this particular Industry 4.0 technology, which is to be tactfully handled. So utmost safety is one of the another important advantages of automation. And improved control. These types of processes are monitored, recorded, which generates the big data, valuable information to identify different patterns, to improve the processes, implement changes to prevent future events. In addition, process optimization opens the door for insourcing, and this infrastructure centralization improves the data quality and consistency that lead to analytical improvement. So these are the list of advantages which we can expect if we are implementing the Industry 4.0 philosophy for running the business. Not only advantages, there are certain issues or challenges, automation challenges in Industry 4.0. First is the investment and infrastructure. Adapting the existing infrastructure to the new one can be a big challenge for the companies, who will have to invest large amount of money and in many cases get access to financing in order to acquire the necessary infrastructure and decide which solution will be the most profitable. So investment and infrastructure development is one of the challenges if we go for total automation of the manufacturing system. Strategic plan, the transition not only depends on investment in machinery and hardware, but require time, a change of the mindset and intelligent analysis and the detailed strategy that maximizes the implementation and capitalizes on the investment. And human factor, actually we are replacing the human labor or human resources by smart devices. So smart devices are no longer working tools, but have become an intelligent workforce, we can say. So millions of jobs are predicted to be lost as a result of automation process. So this is a social concern that when we are talking about advancement or technological development, then on the other hand, there is a chance of the this cost cutting by removing the human forces. Society and large enterprises should therefore encourage continuous training of workers to develop relevant digital skills that complement with the new type of industry. So these are some of the issues or automation challenges which is related to Industry 4.0, investment infrastructure development, strategic planning, and human factor related issues. So this is the introductory part. What is actually Industry 4.0? That is the fourth generation of industrial revolution, where automation takes the front seat, and accordingly, there are different technologies related to automation has been developed, which can give us enormous advantages. On the other hand, there are certain issues which has to be delicately handled. Now, coming to the Industry 4.0 technologies, what are the technological factors which are driving this particular revolution? Industry 4.0 is built on 9 technology pillars. So in the diagram, we can see there are 9 technology has been shown here. These innovations or these technology pillars actually bridge the physical and digital world and make smart and automation systems possible. Businesses and supply chains already use some of these advanced technologies, but the full potential of Industry 4.0 comes to life when they are used together. So technologies has been invented according to the need or according to the advancement of different field separately. But the real advantage of this Industry 4.0 technologies can be obtained when we can integrate all these 9 technology pillars together. Then we can get the maximum advantage or maximum benefit of these technologies which have been developed. So when we are talking about automated systems or automation, so different names comes into picture, starting from robotic systems, where the human labor has been replaced by the robotic system. So we have autonomous robots in different fields. And if we are coming to the manufacturing field, in assembly, in delivering different materials, in processes, we can use different form of autonomous robots. And presently we are using artificially intelligent robotic system, which are having we get various advantages from that. We have digital twins, simulation-based techniques. Not, as I mentioned, it is not always possible to have the physical, practical, or real-world experiment every time when we are going for optimization. So simulation is one of the tools. For cost-saving purpose, also we can go for this. System integration, Internet of Things, cyber security, cloud computing, another technological pillars in Industry 4.0. I'll come to that sometime. Additive manufacturing techniques. Now we have, all of us are aware of conventional manufacturing, which is subtractive in nature, where the raw material is converted into the product, but in the operation or in process, we generate a considerable amount of waste or waste material or wastage. But in case of additive manufacturing, which is a recent development in the field of manufacturing, there are various names given to it. We call it as rapid prototyping, 3D printing. So this additive manufacturing technology has taken a front seat in manufacturing world, and it is showing immense potential in developing different kinds of materials as well as product in various fields of application. So additive manufacturing is one of the very strong tool in Industry 4.0. For different reasons, I will focus on that also. Augmented reality and big data, how to handle the big data and data analytics for artificial intelligence analytics part, that will come into this particular technology pillar. So all these 9 technological pillars actually, when integrated, that gives us the actual benefit of Industry 4.0. So first, so I can go through these 9 pillars one by one. First is the big data. If we talk about the big data and AI analytics. In an Industry 4.0 landscape, big data is collected from a wide range of sources. Of course, this includes capturing data from assets, equipment, and IoT-enabled devices. If we are talking about the field work in the manufacturing part, so from equipment assets, some data can be generated and IoT-enabled devices can generate. Other than these, there are different other sources also. Data sources also extend outside the factory floor into other areas of business and the whole world. They can include everything from customer reviews, market trend that inform the R&D and design, to weather and traffic apps that help ensure smoother logistics. So there are not only the production part or the actual manufacturing operation related part, or rather factory floor, but there are various sources from where the data is to be collected, and we need to analyze it properly. Analytics powered by artificial intelligence and machine learning are applied to the data in real time, and insights are leveraged to improve the decision making and automation in every area of manufacturing as well as supply chain management. So to handle the huge amount of data is a very challenging task nowadays in industries. So big data and AI, artificial intelligence-based analytics system, are very much useful. So I have gathered some of the statistical data or stats on big data and artificial intelligence. So 83% of the businesses that say that artificial intelligence is a strategic priority for their business today. So 83% strategic priority, 95% users of big data to solve the business problem also use different AI technologies. Everywhere we are using knowingly or unknowingly different kinds of AI technologies. Lead the 84% businesses that say artificial intelligence and big data gives them a competitive advantage. 90% interactions managed by both the financial AI related tools that are used by different companies and customer interactions. 95% of the customer interactions are made through different AI-based techniques or AI tools on via phone or any other platform. So these are the some of the facts in present day, means how the AI and big data actually impacts the whole world, and specifically for manufacturing industry also these are relevant. Second pillar is called as horizontal and vertical integration. With horizontal integration, actually processes are tightly integrated at the field level, on the production floor, across multiple production facilities and across the entire supply chain. That is one side. Another side, with vertical integration, all the layers of an organization are tied together. The data flows freely from shop floor to the top floor and back down again. So first one, the horizontal integration part is related to the technology, related to manufacturing or production, and vertical integration refers to or the related to the production management part, how the information is going to the top level from the shop floor. In other words, production is tightly integrated with business processes like R&D, quality assurance, sales, marketing, and other departments, reducing data and knowledge silos and streamlining the operations. So vertical and horizontal integration are very much required for this to get the benefit of 4.0, industry 4.0. And in each of these level, horizontal or vertical level, we use different kinds of automated technologies or automation technologies for different purposes. Third one, this is a very recent keyword, that buzzword what we often encounter, that is the cloud computing. Today's cloud technology provides the foundation for most advanced technologies, from AI and machine learning to IoT integration, and gives businesses the means to innovate. Cloud computing, so to gain the knowledge or to acquire the knowledge, now the knowledge is not confined in the textbook or a library, but the information can be obtained from anywhere, which is there in the cloud. Internet-based systems are there, so we can gather information from any of the sources. The data that fuels the Industry 4.0 technologies resides in the cloud and the cyber physical systems. At the core of Industry 4.0 uses the cloud to communicate and coordinate in real time. So the cloud computing, which actually involves starting from our small electronic gadgets like mobile to huge databases stored in the cloud. Different kinds, the different servers are available for these purposes. So we have different kinds of cloud computing clouds also, where we are getting the relevant information for any of the manufacturing operation we require. Not only the production, but quality assurance, marketing, raw material availability. So everywhere, warehouse management. So everywhere these informations can be applied or used. Another technology that has been invented, that is called as augmented reality. Typically, it overlays the digital content onto a real environment. With an augmented reality system, employees use smart glasses or mobile devices to visualize the real-time IoT data, digitalize parts, repair or assembly instructions, training content, and many more, all while looking at a physical thing like a piece of equipment or a product. So this is a system which gives us the information, one physical system that actually provides this kind of information. So in the picture, we can see everything is available on cloud or on net. From there, we can get the information. AR is still emerging, but has major implications for maintenance, service, and quality assurance. If we are talking about the manufacturing sector, as well as technicians training, safety precautions. So this kind of advantages we can get if we are using this augmented reality. Industrial Internet of Things. Internet of Things and Industrial Internet of Things we can use it as a synonymous to each other. Most physical things in Industry 4.0, like devices, robotic systems, machineries, equipments, products, uses different kinds of identification system, sensors. RFID tag is one of the identification system we can use to provide the real-time data about their condition, performance, or location. And by using these kind of technologies, from remote area also, we can control different kinds of operations or processes. This technology lets the companies run smoother supply chain, rapidly design and modify product, prevent the equipment downtime, stay on top of the consumer preference, track products and inventory, and many more advantages can be obtained. So Industrial Internet of Things is one of the important technologies in Industry 4.0. Next one is additive manufacturing or 3D printing. As I mentioned, Additive manufacturing was initially used as a rapid prototyping tool to make different dies or tools very quickly. If we can, actually, this is a concept what we use in case of printing or making the photocopy of a text or any document. So the same logic if we apply in case of making the product, so that's why it is called as a rapid prototyping tool. But now it offers a broader range of applications from mass customization to distributed manufacturing also. So with 3D printing, parts and products can be stored as a design files in virtual inventories, printed on demand at a point of need, reducing both cost and the need for off-site manufacturing. So basically, if we go through the stages of additive manufacturing, first it will require a CAD file, means the design file of the particular product. If we can make the CAD file of this particular product, what we intend to make, and we can store it in a system. So anytime we can use that design from anywhere, if it is on the internet or on the web. So that can reduce the cost as well as time, and it will reduce the need for on off-site manufacturing also. So that type of advantages can be obtained, and the need for additively manufacturing product or additively manufactured parts are day by day increasing. Not in one thing to mention here, additive manufacturing was primarily invented or designed for the polymeric material because they are well suited for 3D printing technology. But nowadays, or with the advancement of time and technology, we are going for 3D printing of metals also, even ceramic materials, composite materials, and biomaterials. In the field of biomedical applications, the additively manufactured parts are very much suitable, and the demands are day by day increasing. So these are the advantages that has been given in this particular picture: design freedom, sustainability, accurate parts, accuracy and efficiency, and faster manufacturing cycles. But one key point we need to remember when we are adopting additive manufacturing technology or rapid prototyping 3D printing, this is not suitable for mass production or the parts. Say, suppose a cap of a bottle we can make that in a large batch sizes or large number of products can be made at a single run where we have a particular designed die. But it will not be suitable to have or manufacture bottle caps through this additive manufacturing technologies. There are various process variations in additive manufacturing, but they are not suitable for easily available parts or very simple parts. Those parts which are having high value, but it requires in low volume or low quantity, those parts are suitable for additive manufacturing. As I mentioned that in biomedical applications are very much increasing day by day, additively manufactured part. For example, if we require artificial valve for our heart or the stent what we use in heart surgery, those are high value product, but requirement of those parts are not very large. Number of parts should not be very large. So high value, low volume components and products are apt for additive manufacturing, any kind of additive manufacturing. And these are the advantages we can get. These are the advantages against the conventional way of manufacturing or subtractive manufacturing when raw material is converted into different products where wastages are more. So over those conventional processes, design freedom, sustainability, accuracy, faster manufacturing cycles, these are the advantages. If we refer to the design freedom, what it actually means, in conventional machining process, if we consider, as per the design we have made for a particular product, the machine parameters will be set, and according to the design, they will make the part or the manufacturing will take place. But in case of additive manufacturing, during the process, we can change the design, we can change the orientation of the cutting tool, orientation of the product plane. We can change anything, we can go for changing the direction of material flow. So these are actually encompasses the design freedom in case of additive manufacturing. These are sustainable, property wise, very good mechanical properties or other properties which is required or desired that can be obtained, and sustainable also because the material, raw material what we are using for this additive manufacturing, it ranges from polymeric material to the very high strength or high hardness ceramic material also. So sustainable parts can be produced. It can be accurate because there is a least human intervention is required for this additive manufacturing. All the operations that will be performed by the additive manufacturing machines, the process variations are there. So accuracy and efficiency and faster manufacturing cycle. So these are the advantages of additive manufacturing. This is a market research which shows the impact of additive manufacturing. What is the global additive manufacturing market? In recent years, region-wise or application-wise, the demand for additive manufacturing is increasing. And specifically, if we talk about the industry, aerospace and defense industry is one of the most earliest adapters of 3D printing technology since 1989, and different components which are successfully made through these additive manufacturing techniques are used in aircraft or defense equipment. And emerging economic countries like India, Brazil, etc., will have major impact on the adoption of additive manufacturing in the field of electronic and automotive systems. So this is one survey data which has been shown to just to have a glimpse of that what is the impact of additive manufacturing, which is one of the important technological pillar in Industry 4.0. This is one, number 6. Number 7 is the use of automated robots, autonomous robots, artificially intelligent robots. Actually, these autonomous robots are programmed to perform different tasks with minimal human intervention. Autonomous robots vary greatly in size and function, from inventory scanning drone to autonomous mobile robots for pick and place operation. In manufacturing, actually, we very much in any shop floor, the pick and place operations can be done through this autonomous robotic system. In automotive industry, we can see the assembly line, these automated or autonomous robot systems, robotic arms can be used very frequently. And these autonomous robots are equipped with cutting-edge software, sensors, machine vision, and these robots are capable of performing difficult and delicate tasks. Number 8, digital twins or simulation. A digital twin is the virtual simulation of a real-world machine, product, process, or a system based on IoT sensor data. And actually, these digital twins allow the business to better understand, analyze, and improve the performance and maintenance of industrial systems and products. An asset operator, for example, can use a digital twin to identify a specific malfunctioning part, predict the potential issues, or improve the uptime. So the actual product we are going to make, that can be replicated in the digital twin or simulated version, and on that particular digital twin we can analyze or we can perform different analysis. Next is the last one is the cyber security. With the increased connectivity and use of big data in Industry 4.0, effective cyber security is very much paramount or essential. By implementing a zero trust architecture and technologies like machine learning and blockchain, companies can automate threat detection, prevention and response, and it can minimize the risk of data breaches and the production delays across their network. So cybersecurity, for this cybersecurity, for this purpose, we have various platforms are available. Now, all these technologies which are integrated in Industry 4.0 is used for digital transformation. And as we are from production and industrial engineering background, so digital transformation in the manufacturing sector, how it impacts, how these tools can impact on digital transformation of the manufacturing sector. The digital transformation associated with Industry 4.0 brings about both cultural and operational evolution. By unifying and connecting people, data, and assets, it can create an almost limitless range of potential optimization. So integration not only in the process or asset or equipment, integration in data, integration in connecting people. So everything should be integrated in this particular Industry 4.0. And the question is how Industry 4.0 solutions are improving efficiency, visibility, and sustainability in manufacturing and supply chain. How these tools, what have been discussed here, 9 different technological pillars, they are improving the scenario. First is the collaborative design platform. Industry 4.0 supports the creation of collaborative design platform where R&D teams, product designers, and stakeholders from across your organization can access and contribute to design data and insights. This open approach fosters cross-functional collaboration, idea sharing, knowledge exchange, leading to more informed design decisions and the faster development of innovative customer-centric product. So this is one of the unique or very important feature in this particular Industry 4.0 when we are using any of these technologies. Collaborative design, it provides collaborative design platform. Predictive maintenance. We have different IoT tools, sensors, different RFID, many technologies we have already come across. By integrating the IoT sensors and data analytics, manufacturing business can monitor equipment health in real time. So that is under the predictive maintenance part. Predictive maintenance algorithms identify potential failures before they occur, allowing you to implement proactive processes, which can actually reduce downtime up to 50% and which can actually extend the asset lifespan as much as 40%. So these are the various advantages we can get when we are talking about the maintenance related operations. Supply chain is another segment of manufacturing system. Industry 4.0, if we implement these technologies under Industry 4.0, which supports end-to-end visibility across the global supply chain, with real-time data from suppliers, inventory levels, production schedules, customer demand, internal teams, logistics, balance supply and demand, which can be optimized, improve order fulfillment. Order fulfillment can be improved, and it can enhance the overall supply chain and manufacturing efficiency. So for supply chain optimization, these automated tools can be used. And if we go through the different journal articles, journal papers, so lots of work are in progress in the supply chain optimization using this kind of modern tools. Agile manufacturing. Artificial intelligence and advanced analytics allow us to gather and analyze real-time customer insights and feedback from sources like social media, online review, customer support interactions. Then R&D teams and product designers can leverage this data to identify their customer preference, their grievances. their emerging trends. And by incorporating this feedback into design process, the team can quickly develop product products that better align with the market demands, improving satisfaction and loyalty, and driving the innovation. So we can cut down the wastage, so we can make an agile manufacturing. Quality control and defect detection, leveraging IoT devices and machine learning algorithms able to collect real-time data from production line, continuously monitoring and manufacturing the production process, we can detect any kind of flaws or anomalies, identify quality issues, take corrective actions quickly. So these are the advantages we can get. And circular economy practices. The waste management part. Industry 4.0 supports the implementation of circular economy, focusing on reducing waste and maximizing the reuse, refurbishment, and recycling materials. By utilizing big data analytics and IoT networks, we can track product life cycle, implement reverse logistics for product returns, optimize the recovery of valuable resources, many more. AI-powered advanced analytics can also help product designer to develop product right from the drawing board that are built to be more sustainable, waste fewer resources, and more easily recycled or repurposed. So these are the advantages we can go if we can implement the circular economy practices. This is basically waste management, reuse, refurbishment of the material and products. Another one is carbon footprint monitoring and optimization. Actually, these technologies, what has been described before this, facilitate the collection and analytics of real-time data on energy consumption, transportation emissions, and other factors contributing to companies' footprint. By accurately measuring and monitoring the emissions, you can identify areas for improvement, implement energy efficient measures, and develop strategies to reduce overall carbon footprint. And actually, it is related to the one of the sustainability goals what we have come across. So these are the ways how we can implement the Industry 4.0 technologies and enhance the overall value or quality of the manufacturing system. Not only the production line or assembly line or the shop floor, but all the related processes which are coming under this manufacturing of products can be addressed. Now, these are the theoretical parts or the technologies and their implementation in various segments of manufacturing operations. But in real life, what are the advantages the companies have got that we can go through that we can visualize from some of the case studies that I have gathered the information from different organizations. So we can go through 3 different cases, how these implementation of Industry 4.0 can give them advantages in the business. First example is Rolls-Royce. And their actually objective was to servitization in the air. The modern aerospace market is dealing with one of the major challenges of our time at this time, and ever-evolving landscape driven by growing customer demand for efficient, affordable, and environmental-friendly flights. How can airlines remain cost-effective, yet simultaneously decrease their carbon footprint in the face of unpredictable oil prices and increasing regulations? So this particular problem or this particular issue has been addressed by Rolls-Royce in servitizing the air business. Rolls-Royce figured the solution was not just to build better engines, but instead reshape the entire business approach with servitization. Servitization is the shift from a product-centric to service-centric business model and logic, which they have adopted and they have got the benefit. Rolls-Royce realized that the key to success lay not just in delivering cutting-edge products, very good quality or very high-end product, but in fostering the deeper customer relationship or service which is to be provided. Now, but what did that actually look like in practice? So this was their idea, but how to implement that idea, that was done by the Rolls-Royce. So, am I audible?
Yes, sir, you are audible.
Just it was switched. Incorporating advanced digital electronics and automatic engine health monitoring system, they began extracting real-time performance data, leading to the reduced manual checks and smoother operation. So this was the initial stage of their implementation of this particular techniques. This agile approach meant quicker iterations, improved feedback, and more nimble response to the market changes. Today, Rolls-Royce is not just an engine manufacturer, they are solution providers, consistently pushing the boundaries of what's possible in aerospace. They have showcased that true industry leadership is about more than just products, but it's about the understanding and evolving with the market. So airlines now enjoy predictably in costs, increased operational efficiency, and enhanced asset value. So all thanks to a paradigm shifted led by one of the major player, that is Rolls-Royce. This is one servitization in the aircraft business. Next is Toyota, another very well-known cases. Digital transformation to streamline the manufacturing. Rolls-Royce is more about the service provider, providing better services. Toyota is on the digital transformation for streamlined manufacturing. So it has been the global leader in the automobile manufacturing since its inception. So these are the well-known facts for the Toyota. The Japan-based company has been synonymous with quality and innovations. Many tools which we use in industries for different purposes, for quality checking and other inspection purposes, are invented by this particular Toyota company. Amid of the advances of technology landscape, global competition, and rising customer exceptions, the company was quick to recognize the necessity of integrating digital technologies to bring more efficiency and unlock new possibilities. The automobile behemoth set out on a transformative digital journey to augment its manufacturing processes and implement the cutting-edge technologies in its vehicle. So they were the first to implement any kind of advancement in the technology related to the automotive. Starting from design to other services also in the automobile field, they have integrated all these AI techniques, analytics, Internet of Things, robots to automate the tasks and identify the problems in production line, anticipate equipment failure, and address quickly. Toyota also started utilizing the technologies like designing software, CAD and 3D printing to design new products more quickly and efficiently. They have used first, then we have actually following those. The company also invested in virtual reality to simulate the driving experience of new vehicles. The customer who will be buying, they can actually provided the simulator so that they can get the feel how the vehicle run. Besides that, Toyota also invented in machine learning for better quality control that tailored in cars to meet customer needs. Toyota's digital transformation has increased the company's ability to respond quicker to market changes, develop better quality, and reduce cost. And this actually helped the company to remain competitive in the industry and reaffirm its position as a global automotive leader. So Toyota uses this digital transformation or the technologies involved in Industry 4.0 to streamline the manufacturing of vehicles. Third one, General Electric. Reducing the time for designing and manufacturing through digital transformation. So General Electric is another industry or global industry, which is the leading manufacturer of electrical and electronic products. Also, they are in aircraft engine manufacturing, plays a critical role in empowering various industries, including aviation, healthcare, and energy. So, in healthcare, we found different instruments or equipments made by GE. The company faced a series of financial challenges and its profit started to decline during the recession in late 2000. They recognized that existing business model was insufficient in adapting the technological landscape. So digital transformation is the only way or only solution to overcome their difficulties. Recognizing the power of digital technologies in the modern business environment, GE embarked on its digital transformation journey on 2011. The company invested in computer-aided design and 3D printing, which helped them to redefine the product design. So first, they have addressed the designing part by implementing all these technologies which were emerging, CAD, 3D printing, etc., to redefine the product design. Then, with the the company also invested in industrial Internet of Things, IIoT, edge computing, advanced robotics, which enables them to speed up the manufacturing process. Besides, GE invested in AI and data analytics that provided them with factual insights to optimize operational performance. So, as it was mentioned earlier also, and we can see only one technology if we use as a standalone technique, then that will not give us the overall benefit or the full benefit of those particular technology. If we can integrate all these technologies in various domains of operations, some are related to the designing, some are related to the manufacturing process, some are related to the analysis of the data. So everything there, as you can see in this particular case, stepwise, they are implementing all these technologies in various domains. Subsequently, GE accelerated its digital transformation and forayed into the e-commerce arena also. The electronic giant launched an online shopping site for different electronic gadgets, home and kitchen appliances, enabling them to increase the sales, provide a better customer experience. So taking the company's digital transformation one step forward, GE then launched GE Digital, a subsidiary company which provides software and industrial IoT services to oil and gas industry, power generation, and some other industries. Then GE developed Predix, a cloud-based platform as a service for industrial scale analytics. PaaS that collects and analyzes data from machines, helping the companies to improve their operations, increase the productivity, and reduce cost. But their journey was not very smooth, and the company continues to invest in digital technologies to accelerate its growth. Now, however, the electronics behemoth integration and digital technologies steered it through challenging times, making it one of the most exciting digital transformation example. General Electronic example has given in various platforms as a case study how digital transformation given them the advantages, competitive advantages from their competitors or other companies in recent years, in 2000, after that. So these are the three cases which actually tells us the power of digital transformation. Digital transformation means adoption of the technologies which have been included in Industry 4.0 or fourth industrial revolution. All these tools and techniques, if we can implement properly, then we can get the competitive advantage in a very good manner. So this is about the digital transformation and some cases. Now, this is how the Industry 4.0 factory looks like, which actually implements all those technological pillars what has been shown up till now. Digital adaptation platform, streamlined learning, smart energy consumption, intelligent production, routing flexibility, real-time optimization, augmented reality for visualization, predictive maintenance, machine flexibility. So these are the advantages we can get if we implement all these techniques in a factory. And this is how a Industry 4.0 factory looks like. This is one visual representation of Industry 4.0 factory. So I think we have come to the end of this particular presentation. Starting from the Industry 4.0, what is the meaning of Industry 4.0? Through industrial revolution, we have come to a stage where we have full automated, where the shop floor or the factory is fully automated with minimum human intervention. The tasks or the operations will be performed by different machine tools, automated gadgets, electronic gadgets, but human intervention will be required to analyze, because during the process or during the operation, a huge amount of information or data will be generated. We need to properly analyze those data in order to optimize the process or any other purposes that can be served. So for analysis part, human resources are required, but again, they can take help of different artificially intelligently enabled tools, AI-based tools and techniques which are available. In every aspects of life, not only in manufacturing, we use different kinds of artificial intelligence tools in various cases, various platforms. Now, there are nine different technological pillars which is the backbone of the Industry 4.0 concept. If they are implementing the technologies and they are using the technologies as an integrated manner, then what are the advantages they can get that has been given here and presented here, and a few case studies that has been shown how the digital transformation gives different organizations or companies very good competitive advantages. So I'll conclude here, but citing some of the questions, if we want to implement Industry 4.0 in the manufacturing sector, then these are the very common questions or frequently asked questions which are relevant to this particular topic. So with these questions, I can conclude my session. Some of the questions: what are the first steps we should take to get our business ready for Industry 4.0? Are all the type of businesses or organizations are suitable for this technology or not? Is there a way to connect much older machinery to a digital network? Because this is a very pertinent question. Those which are existing or old, should we discard all of them or we can include them in the digital network? do these new technologies integrate with our existing ERP system? Are our existing business systems and databases equal to the running Industry 4.0 technologies? They are adaptable or compatible or not? How do I know which industry technologies are best for our business? How long it will take to achieve our industry transformation goals? Will Industry 4 require a lot of retraining for our staffs? How can we be sure that Industry 4.0 solutions will be adaptable for future? What if we invest Industry 4.0 solution and then our business model changes? How do we respond to concern that Industry 4.0 automation will take away jobs? So these are very common or pertinent queries we are in mind before implementing the 4.0 technology in manufacturing industries. Thank you once again for patient listening. So,
Thank
okay.
you, sir. Thank you so much, sir. Participants, now the session is open for question and answer. If you have any query, please raise your hand. We will allow you to enter we will allow you to enter and interact with the session expert.
One point again I want to mention that all of you have come across the technologies, I think, individually. So in AI, robotics, and other things, some has been given additive manufacturing, also augmented reality. So basically, we are getting those information for different international journal papers because most of these cases are in R&D stages, and there are different web materials are available. So I have gone through this G and those Toyota and other company, Rolls Royce. So all the information are available in the web also. So you can go through.
And at the end, I think you have covered all the aspects, and you all, this is my first presentation in this whole FDP. Where the session expert will present their questions. Okay, this thing I have covered. This type of question you may ask, or I have covered this thing in my session, sir. So that's why I think that they are shy and they are not, they are not asking, they are not demanding any questions, sir. Participants, if you have any question, please raise your hand. We will allow you to enter the room.
I think Datta sir has covered all these things. So the
Yes.
participant have no any question.
Rather, it is a summary of all the sessions. I think all the technologies have been given in the. So I was thinking that in what way I should go for,
Yes,
because it is not possible for everyone to go through all those technologies and tools. Presently, I am just dealing with one of the project which is related to additive manufacturing. So additive manufacturing is one of the areas. Robotics is another part, then augmented reality, cloud computing. So it is an interdisciplinary one now, not only for the production or manufacturing. Computer science guys, electronic guys, so everyone is integrated actually.
Yes, sir.
Anyway.
So thank you very much, sir, for your wonderful session.
And I hope some information I have given so that it will be.
Sir, you have given so many
Yes, sir.
information, sir, about the Industry 4.0, how the technology changes, how the industries are working. This is the good thing, sir. And thank you very much.
You are currently on a project 3D printing.
Yeah, 3D metal.
It's a metal 3D printer also, or FDM type of 3D printer.
Our is wire art based.
Okay,
Printer where material is fitted as a wire.
Okay. So for which material you are currently working?
Yes.
Which material you are using in BAM?
Stainless steel is there and some other graded steel material. Yeah, done through.
Okay, sir. Thank you so much, sir.
Sir, some participant has raised their hand. So I am requesting Dr. S.S. Asraf to please unmute yourself and ask the question. SS Asraf. Preeti. Please unmute yourself and talk to the expert. Yes, I have allowed you to speak. Kindly unmute yourself. Preeti, please unmute yourself. Dr. SS Asraf. Sir, I think no participant is there to ask the question. So we are ending this session
So
over here.
Preeti
No,
has raised her hand.
sir, actually I have allowed to speak, but
There's one more participant.
she is not asking actually.
Okay,
Hmm.
Okay.
So we are ending here.
Okay,
Thank
no
you
problem,
so
sir.
much. Yes, thank you so much, Datta sir, for joining us. We hope we will meet again at 4 p.m. sir. With the another link which have already been shared to your mail ID, sir.
Okay. Thank you. Thanks once again to the whole organizing
Thank
team, and especially Saroj, who has invited me to present this.
Thank you, sir.
An honor, and it's a learning experience for me also. Thank you.
Thank you, sir. Thank you.